students, welcome to Commissionerate of Collegiate Education Learning Management System. In this video presentation, I am going to discuss about two named reactions of carbonyl compounds. They are Perkin and Benzoin Condensation reactions. Myself, Vinny Teja, lecturer in chemistry, SKR and SKR, Government Degree College for Women, Kadapa. At the end of this presentation, you will be able to write Perkin and Benzoin condensation reactions. You can describe the mechanism of Perkin reaction. You can also describe the importance of cyanide ion role in benzoin condensation reaction. And finally, you can also describe the mechanism of benzoin condensation. So, in this video, I want to discuss Perkin reaction and its mechanism first. And later, I want to discuss about benzoin condensation reaction and importance of cyanide ion role in benzoin condensation, and later mechanism of benzoin condensation also. Perkin reaction is the modification of aldol condensation reaction. In case of aldol reaction, two molecules of aldehyde or ketone condense in presence of weak base. Whereas in case of Perkin reaction, an aromatic carbonyl compound undergoes condensation reaction with acid anhydride in presence of a weak base. Benzoin condensation reaction occurs in aromatic aldehydes that have no alpha hydrogens in presence of cyanide ion to form alpha hydroxy ketone, which are commonly known as benzoins. Let us discuss the first named reaction of today's topic, that is Perkin reaction. Perkin reaction was developed by William Henry Perkin. Aromatic aldehydes participate in Perkin reaction. Condensation of an aromatic aldehyde with an aliphatic acid anhydride in the presence of a weak base, usually sodium or potassium salt of the same acid as that of acid anhydride, to form alpha gamma beta unsaturated aromatic acids. If you observe in this reaction, aromatic aldehyde, that is benzaldehyde, reacts with aliphatic acid anhydride, that is acetic anhydride, in the presence of weak base, that is sodium acetate, to give cinnamic acid. Here in this reaction, base is selected in such a way that it should be an alkali salt, that is sodium or potassium salt of same acid as that of acid anhydride. You can observe clearly here that here weak base, that is sodium acetate, is the salt of same acid as that of acetic anhydride. Similarly, if benzaldehyde reacts with another anhydride, that is propionic anhydride, weak base must be sodium or potassium salt of propionic acid. Here in this case it is sodium propanoate. This weak base, that is alkali salt of carboxylic acid, abstracts a proton from anhydride to generate alpha carbanion. Hence, it is the alpha carbon atom of anhydride that reacts with aromatic aldehyde group. Before going into the mechanism of Perkin reaction, let us understand the reactivity of acid anhydride in Perkin reaction. We know that in aldol condensation, sodium hydroxide or potassium hydroxide is used as base to generate the carbanion from aldehyde or ketone. But these bases cannot be used to generate carbanion from acid anhydrides. The reason is, for acid anhydrides, the order of reactivity for enolization is same as the order of reactivity towards nucleophilic attack. That means acid anhydrides can easily get deprotonated by base to become enolate ion, and if any nucleophile is there around, they can be easily attacked by nucleophile. Let us understand this point more clearly by looking at the reactivity of anhydride with strong and weak bases. If the strong bases like sodium hydroxide are used, they hydrolyze the anhydride, giving rise to salt of carboxylic acid. Sodium hydroxide dissociates into sodium plus and OH minus ions. If OH minus ion attacks the acetic anhydride as a nucleophile, then we will get an addition product like this. The electron pair present on O- ion forms a double bond, thereby breaking off this sigma bond gives the product sodium acetate and acetic acid. This is how sodium acetate is formed and acetic acid is formed. Hence, use of strong bases like sodium hydroxide to generate carbanions from acid anhydrides is restricted, and hence no Perkin reaction is possible if sodium hydroxide is used. If mild base like alkali salt of acid, for example sodium acetate, is used, they does not show any impact on the anhydride functional group. Let us see how that happens. Sodium acetate dissociates into acetate ion and sodium ion. This acetate ion, if it attacks the acid anhydride as a nucleophile, it gives an addition product like this. And this addition product rearranges to give back the reactants again like this. This is the sodium acetate and this is the acetic anhydride molecule that is formed again. Hence, when sodium acetate attacks as a nucleophile on acid anhydride, there is no destruction on the anhydride functional group. Thus, use of alkali salt of same acid as that of anhydride is suitable to generate carbanion. Let us understand the reaction mechanism of Perkin reaction. Reaction of acetic anhydride with benzaldehyde in the presence of sodium acetate produce cinnamic acids. Sodium acetate acts as a base. In solution, sodium acetate dissociates into sodium ion and acetate ion. This acetate ion abstracts the alpha hydrogen of acetic anhydride molecule, giving rise to carbon ion, which is resonance stabilized with its enolate ion. This is how the formed carbon ion in step 1 is resonance stabilized with an enolate ion. The carbon ion attacks the electrophilic carbonyl carbon of benzaldehyde molecule to form an addition product that have new carbon-carbon bond. The intermediate that is obtained in the step 2 abstract a proton from solution and forms hydroxy anhydride molecule. And this hydroxy anhydride undergoes dehydration, that means it loses a water molecule on heating to form alpha comma beta unsaturated anhydride. Alpha comma beta unsaturated anhydride undergoes hydrolysis to form alpha comma beta unsaturated acid. When this alpha gamma beta unsaturated anhydride gets hydrolyzed, an unstable intermediate is formed. The electrons are moved like this and acetate ion and H plus ions are removed quickly from the molecule to obtain alpha gamma beta unsaturated aromatic acid, which is nothing but cinnamic acid. This is how Perkin reaction and its reaction mechanism occurs in aromatic aldehydes. The next named reaction of today's topic is benzoin condensation reaction. The benzoin condensation was first reported in 1832 by Justus von Liebig and Frederick Wöhler. The catalytic version of this reaction involving cyanide ion was developed by Nikolai Zinin. It is the reaction between two aromatic aldehydes, particularly benzaldehyde, in the presence of cyanide ion to result an alpha hydroxy ketone, which is commonly known as benzoin. Two molecules of benzaldehyde dimerize in the presence of cyanide ion to give alpha hydroxy ketone, that is benzoin. In this reaction, the two aldehydes serve different purposes, that is, one of the aldehyde donates a proton and other aldehyde accepts a proton from it. Cyanide ion plays a very important role in benzoin condensation reaction. It catalyzes the reaction because it is a good nucleophile. It is a good leaving group also. It increases the acidity of CH bond and stabilizes the carbanion that is formed as a result of loss of proton from carbon. Mechanism of benzoin reaction occurs in 4 steps. That is, formation of cyanohydrin, formation of a nucleophile from cyanohydrin, formation of new carbon-carbon bond via nucleophilic attack, and lastly the formation of benzoin and regeneration of catalyst. The first step of benzoin reaction is formation of cyanohydrin. Potassium cyanide dissociates into cyanide ion and potassium ion. This cyanide ion attacks the carbonyl carbon of benzaldehyde as a nucleophile to form a cyanohydrin. This is how cyanohydrin is formed in step 1. The hydroxide ion that is formed in the step 1 deprotonates the cyanohydrin and forms a resonance stabilized nucleophilic species. Because of the more electron withdrawing nature of the cyanide ion present in cyanohydrin, the acidity of CH bond increases. Thereby, attack of OH- ion removes the proton from cyanohydrin to result in the formation of a nucleophilic species which is resonance stabilized with this molecule. The nucleophilic species that is formed in step 2 attacks the carbonyl carbon of second benzaldehyde molecule as a nucleophile and forms an intermediate that have new carbon-carbon bond. Last step of benzoin condensation reaction is formation of benzoin and regeneration of catalyst. Transfer of a proton and elimination of cyanide ion results in the formation of alpha hydroxy ketone, that is benzoin. In this step, a proton gets transferred from oxygen atom to oxide ion. Simultaneously, cyanide ion gets eliminated as a leaving group, resulting in the formation of alpha hydroxy ketone, that is benzoin. Let us summarize some important points that we have discussed so far. We have discussed about Perkin reaction, that it is the modification of aldol condensation reaction. In Perkin reaction, alpha comma beta unsaturated acids are formed due to the reaction of aldehydes that have no alpha hydrogens with acid anhydride in the presence of weak base. We discussed about benzoin reaction, that it is the dimerization of aromatic aldehydes in the presence of cyanide ion to form alpha hydroxy ketones, which are commonly known as benzoins. We have even discussed about the importance of cyanide ion role in benzoin reaction, that acts as a very good nucleophile and very good leaving group also. And cyanide ion increases the CH bond acidity in cyanohydrin. I hope you have understood this presentation. Thank you.